Oh, I wish the superheroes were here.
And this is heat calculations. Now, before we begin this whole thing, first I have to introduce you the heating curve. This involves the equations of Q equals mcat, Q equals mhf, and Q equals mhv. This is fusion and this is vaporization. Now, here's the heating curve. So, when you use Q equals mcat, it's only here, here, and here, meaning only when the temperature changes. If the temperature is not changing, then you do not use Q equals mcat. When you're doing fusion, which is liquid to solid, or solid to liquid, that is when you use Q equals m heat fusion. Also, here, when you're doing vaporization, then you're allowed to use the equation Q equals mh vaporization. And if you want to find the values of HV and HF, heat fusion, heat vaporization, just look on table B in your reference table and you'll find it.
Hi, I'm MCAT. The Q in my name is named after my great-grandmother Jules. She was so hot. As a matter of fact, her nickname was Heat. Sometimes people even called her KE, short for kinetic energy. The M in my name stands for mass. The C in my name is specific heat. The C represents how easily a substance heats and cools. The delta T in my name represents the change in temperature. As a matter of fact, I am the only equation that is used during an increase or decrease in the heating curve. Let me now explain to you how to use it. If the problem is, how many joules of heat are released when 50 grams of water are cooled from 70 degrees to 60 degrees, then what you would do is this. First, you look for the 50 grams, and that's your mass. So you put that in for your mass. Then, you would see that you have water. Water is always 4.18, and Q equals mcat. Then, you would look for your degree change, and that's 70 to 60. So, you would do your TF minus TI, and you do 60 minus 70. Then you plug it in, and you get negative 29.
I will be teaching you how to use the equation Q equals mhf. Q is the joules, which is energy, M is the mass, and hf means heat of fusion. So, how many joules are required to melt 225 grams of ice at 0 degrees Celsius? So we take our equation, then we take 225, which is the grams, and we take the number 334, which is the number we use for heat of fusion. We multiply that together, and we get 851,770. We use significant figures, which is you take the least amount of numbers, which is 225, we round up, and then we use zeros as placeholders. Then we divide by 1,000 to get 85.2 kilojoules. Then we use scientific notation to get 8.52 times 10 to the 4 joules, which is the final answer.
Hi, I'm Superhero Vaporization, and I will be introducing my problem, which is Q equals mhv. So the problem is, how many joules of energy are required to vaporize 401 grams of water? Because it says vaporize, you use my equation, which is Q equals mhv. So HV is 2,600 joules over grams, which you can find on table B in your reference table. And the mass is 401 grams. And Q is, so basically you substitute the values, and it's Q equals 401 times 2,260. So you find that Q equals 906,260 joules. And basically, you take the least significant digits, and which is 906, which is 3. You put 906 and you use the zeros as placeholders. You then divide 906,000 joules by 1,000 to get kilojoules, which is 906 kilojoules. And to do it in scientific notation, it's 9.0 times 10 to the 5th joules. These can be any answer, but usually the answer in the regions is Q equals 906,000 joules.
Q equals mcat for a temperature change. You can tell the difference if you just use your brain. HF is for fusion, V is for vapor. If you read the question, you're gonna know what you're doing. To find the specific key, divide both sides by delta twice. Liquid goes to gas or blows up in the skies. Hey.